one by one about why all of this is important. And all of these efforts, sometimes are large and sometimes very small, make a huge difference. So thank you. Sorry. The reality of this really does hit me sometimes. Okay, so we could not do this great day without our wonderful support of our sponsors. And so I'd like to thank the Finney Design Group, Curtis Lumber, NYSERDA, and the U.S. Green Building Council. This is so important that they have stepped up and helped us put this on today. And I'd like to thank Sally Hart, who put all of this program together for us. She worked really hard to listen to what you all want to learn about, find the speakers that could help with that, and put together today's wonderful program. So all these sessions are designed to help you learn more and be more successful in your jobs and helping us all do this great work. So I'm going to turn it over to you, Sally.
Great. Thanks, everyone, for being here. Very special day. I'm going to introduce Kevin Stack, our next speaker, our plenary speaker. And you can really go online and find out all you need to know about Kevin. He's just got an incredible background. I'm going to give you a couple pieces, but most important to me is he's been a supporter of this conference since day one. He's been an invaluable resource in helping me, who doesn't know a lot about green building except what I've done in my own home, to figure out the day's agenda and to hook me up with many of you so that we could make this day possible. So thank you very much. Kevin's an ecological builder, building scientist, eco-literacy educator who has been building, designing, teaching in nature's image for over 3 decades. He is a visiting faculty member at SUNY ESF and Onondaga Community College, educating students about building in nature's image, ecological performance standards, building science, and sustainability science and eco-literacy. He also lectures internationally about biomimicry. As a member of the Biomimicry Speakers Guild, he serves on the USGBC faculty, chairs the Lead for Homes 2012 working group, and provides lead coordination, technical support, and rating services to a variety of projects. Please welcome Kevin.
Thanks, everyone, and thanks for being here. I didn't think you were going to read that, so I apologize. Building a Greener Adirondacks, that's why we're all here. That's the name of the conference. I think someday we're going to step back and say, maybe we're going to build a decarbonized Adirondacks in the near future. That may be true. First, I'd like to everyone just take a deep breath. Breathe in and breathe out. Know that the photoautotrophs that surround us in the northern forests just made that possible for us. Photosynthesize, they know how to upcycle carbon dioxide, something that we're having the hardest time in the world about right now, right? They do all this for free. I want to just introduce you to a quick video. Hopefully it's going to come up.
My name is Greta Thunberg. I am 15 years old and I'm from Sweden. I speak on behalf of Climate Justice Now. Many people say that Sweden is just a small country and it doesn't matter what we do. But I've learned that you are never too small to make a difference. And if a few children can get headlines all over the world just by not going to school, then imagine what we could all do together if we really wanted to. But to do that, we have to speak clearly, no matter how uncomfortable that may be. You only speak of green, eternal economic growth because you are too scared of being unpopular. You only talk about moving forward with the same bad ideas that got us into this mess, even when the only sensible thing to do is pull the emergency brake. You are not mature enough to tell it like it is. Even that burden you leave to us children. But I don't care about being popular. I care about climate justice and a living planet. Our civilization is being sacrificed for the opportunity of a very small number of people to continue making enormous amounts of money. Our biosphere is being sacrificed so that rich people in countries like mine can live in luxury. It is the sufferings of the many which pay for the luxuries of the few. The year 2078, I will celebrate my 75th birthday. If I have children, maybe they will spend that day with me. Maybe they will ask me about you. Maybe they will ask why you didn't do anything while there still was time to act. You say you love your children above all else, and yet you are stealing their future in front of their very eyes. Until you start focusing on what needs to be done, rather than what is politically possible, there is no hope. We cannot solve a crisis without treating it as a crisis. We need to keep the fossil fuels in the ground, and we need to focus on equity. And if solutions within this system are so impossible to find, then maybe we should change the system itself. We have not come here to beg world leaders to care. You have ignored us in the past, and you will ignore us again. We have run out of excuses, and we are running out of time. We have come here to let you know that change is coming, whether you like it or not. The real power belongs to the people. Thank you.
15 years old, January 23rd, 2019. Built environment is responsible for over 40% of the greenhouse gas emissions, arguably maybe 41, 42%. 20% of that is from residential construction. We have a responsibility to turn this around. I would say we turn the word responsibility around. We have the ability to respond, which enables us and gives us the greatest opportunity of our lifetimes. As builders of the built environment, we cause this problem, and we can fix this problem. It's ours to solve, and it's right in front of us. It is the largest opportunity we've ever had in a lifetime, and we have a decade to turn this around. This is our future. Their hands are in their hands are in our future. So now each and every one of us to think a little differently. I want you to feel their feelings. I want you to reach out and touch their souls so that they can look deep inside of ours. Make the decisions for them so we can create a sacred place where they can become children again. They can feel safe, part of society, and live the lives that we've had. This is what we need to do. We have a wicked problem. Wicked problem is defined as difficult or impossible to solve. Positive note on that, and let's begin to think differently. A wicked problem is incomplete or contradictory requirements. Embrace uncertainty and fix this. It's social and ecological complexity. It's what's going on in the environment today. It requires complex, adaptive thinking. One of the touchstones of biomimicry. Resilience thinking. Solving one aspect may create other problems. That's a wicked problem. Safe enough to try? Are we at a place where we know enough to actually just step out and try something rather than talk about it? Can we do this? I know many in this room, and I know we can do this. I'm 100% confident, and I know we can do it in a decade. It's estimated that over 83,000 new buildings need to be built in New York State alone just to meet the goals set by our current governor of 100% renewable energy by 2040. Over 80% of the buildings in New York State are currently built and living right now. They're alive using fossil fuels. Every home or building built that uses fossil fuels just digs the hole deeper for us. Makes us harder to get out of it. It doesn't even give us a starting point. We need to think differently. This is a slide normally we see from Rocky Mountain Armory 11s that's tunneling through the cost barrier. We've never been able to do that for zero energy. We just haven't gotten there. It's either too expensive, too hard, and certainly we haven't been able to electrify our buildings. We've always relied on fossil fuel. But how about once we break through that cost barrier? Instead of the resources, capital costs that we normally save, we're actually saving the earth itself as we know it today. How about we look at that a little bit differently and what it's going to take? Certainly fuel switching is the buzzword today, and emissions rather than energy efficiency is what we have to start thinking of. This is how we all think differently. This is the global impact of the built environment. This is a photograph taken in Syracuse, New York on a cold winter's day. See that our buildings are alive. They actually inhale fresh air just like we do, and they breathe out toxic emissions. This reminds me most of Rachel Carson in her book over 56 years ago, when she said a change in one molecule even can reverberate throughout our entire systems and bodies, initiating changes that are unknown and unseen. This was a wicked problem for her, and we've solved that problem mostly, right? This is important. Back in the 1960s, this is referred to as Rachel Carson's fable for tomorrow. I would say our fable for tomorrow is how to decarbonize our grid and our homes and our lives. Just close your eyes and imagine the wire, right? How about we just close your eyes and imagine a world that runs on 100% renewable energy? Buildings in which we work, learn, and play that clean and purify the air and water that we breathe. We know how to do this. We just need to do it. We need to start. We have a safe place to start from. We need to just begin to do it. Buildings that operate on what's referred to these days as a fair share principle. The Haudenosaunee, the Iroquois nation, used to refer to it as take what you need, all that you take. Share the rest. Decarbonization. I'm sure all of us in this room understands what it means. But think about this before each and every one of us goes to bed this evening. 170,000 people will have moved to the urban environment. Paradigm shift. Big shift. We're all going to be living differently. Our children are going to be living differently. In New York State, 60% of the greenhouse gas emissions come from the operations of these buildings. 60%. Decarbonization is a big, big move. And here's the 3 pillars of decarbonization. Our energy policies must shift carbon emissions, not to energy efficiencies. Fuel switching. Our priorities have to change from cost effectiveness, zero greenhouse gas emissions. Zero greenhouse gas emissions just not only refer to our appliances, but also our cooking. It's said in the state of California, who doesn't just have a goal. When Jerry Brown retired, before he retired, he set a law into place. By 2045, they are zero carbon. It's a law. Their cooking appliances will be all electric. That's their hardest spot to get over right now. People who like to cook with gas are going to be cooking with electricity, and they're proving it. So complete decarbonization of electricity, electrification of lower carbon fuels, it's all fuel switching. So this is a walk I take every morning. I get to walk by my PV array. As I go up onto the hill, whether it's in the morning, early morning, or late in the evening, I can look up into the stars and I see the Pleiades and Cassiopeia and the full moon that we're going to see tonight. Pretty spectacular. But I also get to walk by this gas well. I'm in a remote location in Vesper, New York. basically unheard of. And there's $1 million gas well that's in place that goes down 6 miles, takes a 90-degree turn, and goes another 2 miles, go underneath the conservation area, just waiting for New York State to allow fracking. This is what I walk by every single day of my life. What fuel switching is all about, and this is what we're up against. It's $1 million investment right next to my house. My daughter called me up one morning and said, "Hey, Dad, there's a helicopter flying over our pond. And it just dipped its borehole into our pond to cool it off. Its rig was dipped into my pond." This is my system of renewable energy. Quite proud of it. It was $32,000 before incentives and tax breaks. And it took me many, many years to get to the point where I could actually afford this. My operations on the electric side was down to $1.17 a day. I don't use a lot of electricity. But I can't stand here and talk to anyone without doing something like this. In the end, I think my total investment might have been $11,800. I did most of the work myself. The first day of operation, couldn't believe how pleased I was. Fair share, using my fair share and placing the rest back on the grid for others to use. This is day 2. Net zero production. Not there yet. Mine's on the ground. I have the ability to clean it off. On our rooftops, they're actually quite dangerous. They're like snow slides. They operate efficiently when the sun's out, but not when they're dirty or covered. Snow actually covers them. They come down all at once. I had the opportunity to build for a great friend of mine. He said, "Kevin, load up my roof with PV panels." Rick Fedrizzi. Within 2 weeks, he called me because the snowslide come down and almost killed his puppy. They're difficult decisions we need to make. Where to place them, how to put them. Now the codes are involved to how many we can put on there for health and safety reasons, so that the first responders can get up onto the roof and put the fires out. Here's the problem. Did a presentation 5 years ago based on a trip I took to Hawaii to move my daughter back to Portland, Oregon. When I met the people who were going to purchase her car, they had PV arrays on their rooftops, but they weren't allowed. It was against the law to turn them off. There's no place to put the excess electricity. And I thought that can only happen on an island. Then I found out that it happens in the state of California. Today, California pays Nevada and Arizona every day for them to take their electrons. They pay them to take the electrons away because of the harm it does to their grid. This is the duck curve. This is why the ramp at the neck of the duck, at 13,000 megawatt ramp, is when everyone comes home. You can't turn a grid off that's based on natural gas or coal. They can't ramp up and down that quick. So when electricity is in there, you're overtaxing the grid and you're actually hurting it. California couldn't release theirs because Pacific Gas Corp, the only place where the ISO operators could move it to, are on zero coal as well. So the minute they did their shared electrons, they go in each direction. So they couldn't share it with the neighboring states, otherwise they'd upset their coal budget. This is the English doctrine of ancient lights, something my son, who's a lawyer, introduced me to. And this is what it is on the other side of the pond. And it pretty much states that if you have not shaded your neighbors in the past, you're not allowed to shade them in the future. It's been in the Supreme Court 3 times here in the US and 3 times it's failed. We don't have those rights unless they're purchased. Difficult. Ralph knows California has created how we should make our subdivisions. I build in subdivisions, I build on zero lot lines, I build all over the state, mostly in the Finger Lakes, and I can tell you, we don't get to choose where we build, but we can choose how we build in the future. That's a starting point. That's something we can solve quite easily. Lay out our new subdivisions so that everyone gets their fair share of light. so that we can share our resources together. It's no longer you and me. It's no longer I. It's you and me. It's we. We have to do this together. This is what we see today. This is a new net zero community that has no idea where the sun is or where the snow is going to fall or where the rain's going to end up. Such a simple thing. It's so simple. The diagram on the top left was published over 45 years ago. The basis of everything the sun can give us today. The 4 kilowatts per square meter per day of resources. Enough resources that hits the earth in a day that can power all our houses for a year. If only we know how to harvest it. I mean, look at we're all builders in this room. Designers, architects, builders. We all live in houses, and this is the best we can do. Don't like to critique things, but it's like Greta says, we need to speak up. When things are wrong, they're wrong. We need to start doing things differently and thinking differently. Geothermal geothermal wells to get off of natural gas, right? Look at the harm. The photograph is on the right. I was actually taking a picture, and we're drilling one 400-foot well alongside, actually 20 feet away from the other well we just dug. This is what gas fracking is like. The pressure of the drill rig pushing the water down, fracked across, and everything came up the other well. It actually contaminated 2 different wells on us, and we had to go back and rebore and clean them out. Look at that excess spoilage on the ground. This is difficult to come up with. This is a 25-ton system, 12 wells, each 400 feet deep, to make a house net zero energy. Electrification equals refrigerants. We move from greenhouse gas emissions, worried about CO2 emissions, refrigerant emissions. We went from an R22 refrigerant to an R410A. We have the efficiency. We need twice as much R410A to be as efficient as R22. If R410A has half the the global emissions potential of R22, what does that tell us? We'd have to use twice as much R410A to equal the R22. Got it. Where are we going? This is our answer. Mini splits, ducted or ductless, refrigerants that are going to come back. This is thinking differently. We need to think far in advance. I own and operate with my son Josh multiple office buildings. On a hot summer day last year, I got a call from the dentist. The temperature was 89 degrees. We had to do a change out. I'm a building owner, and I'm standing here talking to you today about this stuff. It's 89 degrees in a dental office that's full of patients. Dentist needs the temperature to come down. It was 91 degrees out, so we couldn't open the windows. Marty shows up, and I says, Marty, I want this completely changed out from an R22 to a R410A system. He goes, Kevin, it's 3 days. 12 patients inside in chairs. How do you make a decision like that? To replace a complete line set, get back to the evaporator so it matches the condenser on the outside. It's a 3-day job. Somewhere in the range of, I don't know, $4,500. So he changed out the system. He captured the R22. We kept the same SEER rating of 12. And it operates as it is today. And I'm standing here before you. I'm guilty. I don't know how to fix this unless we future-proof our buildings. That means we have to do it today. We have to start today with an investment of no fossil fuels and future-proof them so we can plug and play, so we don't get caught in situations like that. The answer, my friend, is blowing in the wind. This is part of our answer, right, off the coast that we're looking for. Hopeful, no refrigerants, some ecological impacts. How many know where the word threshold came from? Surely Mike must know. I see a couple people back here. So this is a threshing barn, right? So threshold actually came from the size of the boards across the entry. And our barns weren't aligned on the east-west axis for the solar exposure. These barns were aligned to catch the free energy of the wind. So as the wind came through and we winnowed and thrashed the grains, the heavier grains fell down. The threshold was the board that kept the grains in, and all the waste products blew by outside. Today we can capture those waste products, put them together with non-formaldehyde glues, and put them into our sheet goods. But it's also the power of free wind energy. This is the way EPA feels we should be. This is us. 2006, 8 climatic zones. My son Josh lives in a 144-acre farm that's over 100 years old. The front of his house is in Onondaga County. The back of his house is in Madison County. He's in climate zone 5 and 6. Golly, I think the back of his house needs different insulation than the front of his house. What do you think? This is the way we do things. This is EPA. In 2006, they thought they had to make it easier for the code officers. So reduce the climate zones to only 8. New York State has 3. I came through 3 climate zones just coming from Sally's camp to here today in a 20-minute drive. 3. When I went to San Francisco for Greenbelt, I was the last one in for a wine tasting tour, so I jumped in an old VW bus. Guy had a tape deck. He was playing Red Wine. He crossed the bridge. He said he was on the Mike Douglas show. There were people in the back seat from Canada who were Minnesota Vikings, and people in the center seats from Wisconsin, and they were the Green Bay Packers, and this was not a fun trip at all. And we pulled up to an old farmhouse that didn't even look like a winery, and a 25-year-old woman come out. Down the steps she came. First thing she said changed my world. She literally turned my world upside down. She said, this is a 2 to 3 acre vineyard. It used to be a dairy farm. And there are 28 climatic zones as you go up and over this 2 and 3 acres. She told me how the climate zones go from the base of the roots up into the vines, right out to where the grapes are formed, and how they manage for each of those 28 climate zones to produce the grapes and the wine that we drink. Think about that. And we don't even know enough to do it for their houses. So I changed from a cardinal direction orientation for vapor barriers, vapor retarders, air impermeable, to vertical ones. I use 28 climate zones on every house I look at, and I can find them, and I can seal them, and I can let the air pass through. It's up to me. When I build on the shores of Skaneateles Lake, it's totally different when I build in the hills of Tully. I use different insulation materials, different ways of air sealing. I place my vapor retarders and vapor barriers in different areas. I use cellulose versus fiberglass. I try and use natural insulation products, but my air sealing protocol changes based on those 28 climate zones. This is how we get to net zero. PS Plus, Passive House Institute in the U.S. How many climate zones they feel we need. They're adding to it all the time. There's over 100 climate-specific zones that we manage our loads for in manual J calculations. Just this past week alone, ACCO released a new version of manual J for a low-load house. Year 2019, and it's taken them that long to respond to what we're doing today, what we've been doing for 20 years. I know most of you in this room, and I know you guys are doing it right now. And we finally have a tool that tells us we can use stuff under 1.5 tons, and it works. You can have a 12 to 16,000 BTU appliance, and it works. And now Manual J is actually showing us the way. We have ways to manage our emissions. This is where we're thinking differently again. This is where we need to change. This is where we become not about energy efficiency. Our policies, our energy policies don't react to this. This is about the emissions. So thinking differently, it's not the cost on our utility bills, it's the emissions. We need to do this, and there are tools out there that we can use. AVERT is just one of them. It manages on an hourly basis the energy that's produced, the source energy that's produced. Think of that. And it's telling us what the emissions are. It doesn't capture all the source energy. It doesn't capture the transportation, the movement of electrons. Actual people are doing the work to get it to light the room, the lights in this room here today. But it gets most of it. It's a great start, and it's an easy tool to use. We can plug our data into this tool and not just gauge our energy cost, but our emissions. And we need to know this, or we're not going to get to where Greta wants us to be. We're not going to be helping our children. We won't be able to create a sacred place for them to live their lives like we've lived ours. How many are invested? I have a construction manager, an architect, passive house consultant, and a building owner in this slide. And we're standing in an 18-inch I-joist, the first of its kind ever. Ever. They wanted to dump cellulose in this. What they called for. I can't imagine anyone in this room not knowing the implications of filling a 10 or 12-foot tall wall with 18 inches of cellulose. Need to think differently. We need to understand the second law of thermodynamics and all the natural laws. They give us our answers, and it's right in front of us. We need to do this. R is an acronym for active, engaged, responsive. What we need to be. This is us. This is the we. We are the doers. We do the work. No one hears about our work until they performance test it. No one knows about the caulks adhesives, the stuff that we breathe and feel and touch, everything that we've gone through, from the silica rules to the pressure-treated lumber with arsenic in it. No one ever thinks of us. It's us who needs to do it. May not get credit for it, but someday, when Greta's 75, she'll know who we were and what we stood for. Occupant behavior. We can do it, but what happens when we turn the key over? I know you guys in this room can build a net zero energy house. I know you can. I've seen them. I've heard them. I've read articles about them. I've seen the beautiful photographs. But what happens when we turn the key over? What happens to that net zero energy home or zero greenhouse gas emissions? Where does it go? Do they know how to operate it? Do they understand the differences? I always tell this joke, my son's going to kill me someday. He's literally going to walk up here and punch me. When on his honeymoon, he went to some remote island in Hawaii. The first morning he called me up, and he goes, "Dad, listen to this." I go, "Josh, you're on your honeymoon." "No, listen to this." I open up the sliding glass door, and the air conditioner turned off. Simple solutions. Simple solutions that work. And I said, "Josh, it's your honeymoon. Don't be calling your dad." Performance testing the day before Christmas. The day before Christmas, the code officer is asking the people that they let in, move in on a TCO, to move out. And I was called in to come down and performance test, and this is what I find. Ductwork that didn't pass the test. Blower doors where we couldn't get an ACH 50 below 5. No mechanical ventilation. Fire detectors that are removed so the occupants can live the lives that they want to live, supposedly, I guess. I didn't even know what that thing was by my micromanometer until I showed someone this picture. I said, "Oh, now I know why the smoke detector is disconnected." Over 35 builder-installed devices that draw power 24/7, 365 days out of the year, and most of these are demanded by code. When I go to bed at night, if I fall asleep in front of my wood-burning fireplace, I'm looking at 7 LED lights that stare at me all night long, and I wonder why. Why they have to be there. Why do they need to draw energy if my goal is to get to zero energy and below? We need to rethink optimum value engineering. I'm the biggest proponent of optimum value engineering ever. I know about removing lumber from walls and replacing it with insulation. Take out R4.5, place R21 in the wall assemblies. It's simple and it works. 75 mile per hour gust, New York State 2 weeks ago. 150 mile per hour gust on the coast 3 weeks ago. A bomb cyclone in the middle of the United States. These fortified buildings, when we use optimum value engineering, we better think hard about what we're going to remove and why, and if we can stand up to climate disruption. Coming, we know it, we see it, we feel it, we hear about it. We know that people get hurt by it. We need to react to it. Aware, responsive, and engaged. Hurricane Katrina. A police officer, there's no way I was going to buy a flat roof house. The Make It Right Foundation, where every house was LEED platinum, and they're all falling apart. This is us, this is we. There are our systems, our rules, our processes. No engagement, no awareness. Don't respond to it. They're sitting down there like this today. As we sit up here in the Adirondacks, that's what these houses look like. House on the left, lower 9th Ward. House on the right, Syracuse, New York. Syracuse, New York. Flat roof houses. Resilient Corners, fully funded project, net zero, passive house. Are we aware of what we're doing? You understand movement? These are my tools. 5 minutes to questions? Or?
Yes.
Okay, thank you. So, I live in the northern forest. I know what these are telling me. I know how to build the houses. I know how to orient my houses when I have the opportunity to change them. I know which way to put your shingles on from the ridge caps to the start. I know which way to orient my siding. And it's not like this. I know how to layer tens of thousands of feathers to survive in the Adirondacks when it's minus 40 degrees. This bird is no bigger than my thumb, the golden crowned kinglet, and it stays here. It does not migrate. It stays here. It lives minus 40 degrees because it knows how to orient its feathers properly. And we can't do this in our buildings, but nature can. Who would have known that for the entire Industrial Revolution, we thought smooth, slippery surfaces would be the cleanest? Japanese revered a lotus plant because it's so clean. It comes up from the mud flats every spring, and it's sparkling clean. And when you look at the plant surface, it's actually bumpy. It's not smooth. It's called the snowball effect. When rain hits it, it's like rolling a snowball up to make a snowman in the winter, and it actually picks up all the leaves and debris on the ground, and it washes our facades. This is not just what our EFIS system should be like. This is what all our systems should be like, from our fenestration to our sheathing goods. How about no VOC? Sure, Stephanie has something to show us out here in the halls that prove this out. The color of the butterfly here is actually brown. It has no color. It creates its own color. research institutions in New York, they're actually trying to do this in the paints. They're trying to mix little PV panels, so you can put a rheostat on the wall and change the paint color just by a rheostat. Paints with no VOCs or low VOCs. Nature does it. Nature does this every day. Can't. This is where we need to think differently. Historical and scientific knowledge, a barn from 1888, I own it, and I'm amazed at how well it survives. So now we take that same sloped header and we pack it in behind our trim. So when we move our sheathing away from our siding, away from our sheathing, we have a space we can actually deflect water behind it. So when the water gets in, we're literally just teaching water how to walk again. We're showing it where to go, we're not trying to stop it. Letting it go right around the window, and we're building it into our systems. This was taught to us by our great-great-grandfathers. They knew how to handle moisture. They knew how moisture is. Nurse species. We're going to need these solutions, and we're going to have to build them and watch them fail, and build them and watch them fail till we get it right. Because the nurse species, they're going to teach us, and they'll teach us and show us the way. Different ways of putting things together, rather than fill foam that forms our formwork for our foundations. Couples us, but separates us from the earth. Natural wool and cork insulation for zero release of VOCs. Pure indoor air quality. Our framers become the air sealers because they're there before we can get there. They have the opportunity to do this before our air sealers have to come in and try and find places to come into. Wrapping our roofs down to our siding and let them touch, and then attaching our overhangs. Chainsaw effect of what we do on the older houses. Take all the overhangs off, seal the walls to the roofs. Well, how about we do that and future-proof our houses? Let's wrap our EFIS system or our ICF systems up and touch our SIPS panels with it, and then place our overhangs on. Let's build smaller, more efficient, and more beautiful structures. 900 square foot structure that I would love to live in. When I built this one, I didn't want to let it go. Remodeling systems. When we remodel, we have an opportunity. It's like a generational opportunity to seal up our exterior. Take our foam products, if we must use them, and place them outside, not inside, away from the indoor environment. Gray water linked to solar thermal, linking systems together, finding solutions that optimize other solutions. Solar thermal panels on our roof that have to release the energy, dump them into the cistern. And this one, we just took a 3/4 inch coil of copper, placed it in there, and we route the water around rather than releasing it. So if the solar thermal system's too hot, the water goes in the system, the gray water goes in there as well. We optimize it again, and we turn it into putting our gray water and black water in there where we clean and purify the water before we release it from the site. Systems on site, decentralized. Building phenology. This is us. Again, it's us. Not you or I, it's we. Me. What do we want to be known for? We're the builders, we're the doers. We make places where people live, work, and play. We create these structures. It's up to us to fix it. I'll end that same thing I started with. We have the biggest opportunity we've ever been given in our lifetimes. And we have a decade to do it. If you want to look at it as a profit motivator, that's fine. But we can fix things for our children. And these sacred places that Greta talks about, they're our homes, where we live. Thank you.
We have time for some questions. right, well then we'll exit out, have a little break for coffee, and then we'll have our next plenary at